Hello and welcome to Wheelock College for today's segment of Inquiry in Action. I'm your host, Dr. Chuck Fidler, and today we will be exploring liquids. As a result of this lesson, you should be able to demonstrate an understanding of liquid surface tension, understand the difference between adhesion and cohesion, and understand basic molecular polarity. Water is a very cool substance, and we have all had an abundant experience with it in our everyday lives. Have you ever seen water droplets flow down the window during a rainstorm? Or seen raindrops splashing into puddles? How about the surface of a very calm lake early in the morning? It turns out that water has a very special property called surface tension. Let's take some time today exploring properties of water and other liquids to see what we can learn. To do this experiment, you will need the following low-tech materials and equipment, which include water, an eyedropper, regular salt, dishwashing detergent, clean glass jars or porcelain bowls, measuring spoons, and a penny. These common household items are a great way to discover some cool science you can explore at your own home. So, off to the lab, or a kitchen, basement, garage, den, wherever you are. Do you ever use pennies anymore? In today's experiment, we'll use them to explore the laws of nature and the interesting concept of surface tension. Hello again. Let's get started with our inquiry-based experiment. Remember, allow yourself to be curious, ask plenty of questions, and enjoy being a learner. Holding the eyedropper close to the surface of the penny, carefully drop water droplets onto the penny, one at a time, counting each drop. Here's a tip for you. The droplet should pool up on the penny, creating a big droplet of water. To make sure your count is accurate, hold the eyedropper far enough above the penny so that the drop has a short distance to fall before fusing with the droplet on the penny. Stop when the droplet on the penny breaks up and overflows. Count all of the drops except the one that caused the penny to overflow. Next, try the same test with the salt solution. Add and dissolve 1 teaspoon of salt to 100 milliliters of water and repeat the dropping procedure. What do you think happens to salt when it is dissolved in water? How do you think adding salt to the water will affect the hydrogen bonds between the water molecules? Do you think salt water will have more or less surface tension than plain tap water? Finally, try this test with the detergent solution. Add 1 drop of liquid dishwashing detergent in 100 milliliters of water. Do not shake the container or else you will produce suds. Gently tip it back and forth to mix and repeat the dropping procedure. What do you think happens to detergent when it's dissolved in water? How do you think added detergent will affect hydrogen bonds between water molecules? Do you think water with added detergent will have more or less surface tension than plain tap water? Repeat the measurements 3 times for each solution and enter the data into an organized table in your science notebook. I have a challenge for you. Compare how all 3 liquids behaved when dropped onto the penny. What effect did the addition of salt and detergent have on the surface tension of water? Think about this at home, but for now, let's head back to Inquiry Central. Water's surface tension is based on the attractions between water molecules at the surface and the water molecules in the rest of the water. A water molecule beneath the surface feels attractions from all the molecules around it. But the molecules at the surface only feel attractions from the molecules next to them and beneath them. Therefore, molecules are being pulled together and inward, getting compressed and forming a tight arrangement like a skin over the water's surface. This is what we know as surface tension. The inward pull from the attractions of the molecules results in the smallest possible surface for a volume of water, which is a sphere. This is why water forms a round drop or dome on the surface of a penny. Detergent is made from molecules that have a charged end and a longer uncharged end. The detergent molecules spread out over the surface of the water with the charged end in the water and the uncharged end sticking out. The water molecules at the surface are attracted to the charged end of the detergent molecules. As these surface water molecules are pulled outward, this acts against their inward attraction that was creating the surface tension. This reduces the surface tension and causes the water not to hold its round shape and spill. Surface tension is the property of a liquid by which its surface acts as a stretched elastic membrane. An increase in dissolved inorganic salts causes a rise in surface tension, increasing the attraction of the surface to the underlying molecules. This tension allows insects, such as a water strider, to stand on the water's surface. I hope you had fun getting below the surface of surface tension. This is Dr. Chuck Fidler for Inquiry in Action. Keep your pennies salty. We'll see you next time.